In today's chemistry riddle, we start with this sugar derivative having 3 methoxy groups and this methane sulfonic ester functionality sitting here. A reaction takes place with sodium methanolate in DMSO. DMSO, a very polar solvent. And as the final product, we have that sugar derivative exhibiting overall 4 methoxy group. So clearly this sulfonic acid ester has been substituted by a methoxy group. We should pay attention to the overall stereochemistry of this reaction. It is a reaction under retention. And therefore, we now already know it's certainly not a nucleophilic substitution according to an SN2 process, because that proceeds with a typical inversion of stereochemistry. What about an SN1 process? Well, could be. That means the leaving group is leaving the molecule first, forming a carbenium ion here, and this carbenium ion has been trapped by the methoxy group, by the methanolate, and the methoxy group will end up in the thermodynamically preferred equatorial position. However, a control experiment has been made with a special isotope of oxygen, and this special isotope, the 18 oxygen, was not found here in that molecule. If the SN1 process would be the real proceeding mechanism, then we should find the isotope here with that oxygen. Well, that means it could not be an SN1 process. So, how can we solve this riddle? Well, if it's not an SN1 process, that means there's no carbenium ion formed, and if no carbenium ion is formed here, what is the electrophilic center in this molecule? It's the SO2 group here. So, methanolate will attack at that sulfur addition elimination process. Let's abbreviate this a little bit. You omit these substituents. We will have an alcoholate with the sodium countercation, and here we have that marked methoxy group sitting at the SO2 group. Now, here we have a typical leaving group and a positively polarized carbon there. This is now the electrophilic center, and this is within one solvent cage together with this sodium alcoholate. So this could react in an SN2 process, substituting that sulfonate. The final product here is formed, and the sulfonate will end up as the isotopically marked sulfonate, sodium sulfonate. Thanks for listening.